Good morning to all of you. Now, today we will do thermodynamics, engineering thermodynamics. Engineering thermodynamics. Now, I will discuss what is Joule's law. Last class, I have discussed different laws. Clear? Now, this is Joule's law. The law states that the law states that the change in internal energy, the change in internal energy of a gas depends upon its change of temperature. Clear? The change in internal energy of a gas or given mass of gas depends upon change of its temperature. That is, del U is directly proportional to T2 minus T1. The del U is change in internal energy. This is change of temperature. This implies delta U is equal to constant into T2 minus T1. This implies del U is equal to Cb into T2 minus T1. This is for 1 kg of gas, and del U is equal to mCb T2 minus T1 for m kg of gas. This is del U, change in internal energy, where delta U is equal to change of internal energy, m is equal to mass of the gas, Cb is equal to specific heat at constant volume. Clear? Cb. T2 minus T1 is equal to change of temperature. Clear? Next, enthalpy. Enthalpy. H. Enthalpy is defined as the sum of internal energy and the product of pressure and volume of the gas. Volume of the gas, that is H is equal to U plus PV. Clear? Internal energy plus product of pressure and volume of the gas, where U is equal to internal energy, U, P is equal to pressure of the gas, P is equal to volume occupied by the gas or volume of the gas. Clear? If there are two conditions, initial condition, final condition, then if one represents initial condition of the gas, initial condition of the gas, clear, one represents, two represents final condition of the gas, clear, then what is H1? U1 plus U1 V1. What is H2? U2 plus U2. Clear? Now change of enthalpy. Now change of enthalpy. H2 minus H1 is equal to U1 plus U2 plus U2 V2 minus U1 plus U1 V1. This is delta S. This is delta S is equal to U2 minus U1 plus V2 V2 minus U1 V1. Clear? What is delta E? This is delta E. MRT2. What is P1 V1? MRT1. Clear? Where U1 V1 is equal to MRT1 and V2 V2 is equal to MRT2. Now, what delta U? We have already derived delta U. What del U? M CB T2 minus T1. Put this value here. This is del H. Change of enthalpy delta H. What is del H is equal to M CB T2 minus T1 plus this plus MR T2 minus T1. Clear? Now, common T2 minus T1 and M. So, del H is equal to M C plus R T2 minus T1. What is C plus R? I will derive Cp minus Cb is equal to R. What is Cp is equal to? C plus R. Put here Cp. This is equal to Cp. So del H is equal to m Cp T minus T1. This is change of enthalpy delta H. Clear? Next I will derive some expressions of different type of process. Types of process. Types of process. Types of process. This is mainly 5 types. Number 1, constant volume or isochoric. Isochoric. Number 2, constant pressure or isobaric. Isobaric. Number 3, constant temperature or isothermal. Isothermal. Number 4, adiabatic. Number 5, polytropic. Clear? I will derive expressions for these following 5 processes. I will find out for each process what is work done, what del U change in internal energy, what heat transferred, what change in enthalpy. Clear? For all these 5 process, these 4 quantity can be found out. First I will discuss what is constant volume process. Clear? Constant volume process. The volume of the gas remains constant. Clear? Suppose this is volume, this is pressure, this is volume 1, 2, process 1, 2. In this process, this is V, this is P, this is V1, this is V2. Clear? So V1 is equal to V2. What change of volume dV is equal to V2 times V1, 0. What is work done? Double O. P into V2 times V1 or P dV, or what is work done? W is equal to integration of P dV. This is 0, so what done is 0. Clear? I will explain what is constant volume process. When the gas is heated, in such a way that the volume remains constant, the volume of the gas remains constant, remains constant, then the process is called constant volume or isochoric process. Isochoric process. Clear? The volume is constant, means V1 is equal to V2. In this case, the work done in this case there is no work done by the gas. Clear? That is W is 0 or work done is 0 or W is 0. W is equal to 0. But heat can be supplied. The heat supplied is utilized in change of internal energy. The heat supplied, the heat is supplied or the heat supplied is utilized, is used for change of internal energy. Clear? According to law of conservation of energy, what dq is equal to, or what is q is equal to, W will tell you this is 0, what is q is equal to delta U. Clear? We have already derived it according to Joule's law, what del U is equal to m cp T1 T1. Also, when heat supply constant volume, also when heat is supplied at constant volume, then what is q is equal to m cb T1 is T1. Clear? This is q is cb. Now change of enthalpy. Change of enthalpy. We derived earlier del H. What del H? M Cp T1 is T1. Clear? So in this process, del U is equal to 0 or W is equal to 0, not del U. W 0, del to M Cp T1 is T1, Q mCp T2 minus T1, del H change enthalpy mCp T2 minus T1. Clear? Next, constant pressure process. Number 2. Number 2, constant pressure process, isobaric. Pressure process. Isobaric. Isobaric. This is constant pressure process. This is volume V. This is pressure P. Suppose this is process 1, 2. Clear? In this process, this is 1, volume V1, volume V2. Here, P1 is equal to P2, is equal to P. So what is what done? Area under the curve 1, 2. This is what done. This forms a rectangle. What is length? V2 minus V1. What is height? P. What is the area of rectangle? Length into breadth. P into V2 minus V1. In PV diagram, the area of the figure, area under the curve is equal to work done. Clear? This is called isobaric or constant pressure process. When the gas is heated, in such a way that the pressure of the gas remains constant. Then the process is called constant pressure process. Constant pressure process or isobaric. Clear? In this case, the total area under the curve 1, 2 represents the total work done. Clear? Consider the process 1, 2. Process 1, 2. In which the pressure remains constant. Pressure remains constant. that is P1 is equal to P2. Clear? But volume changes from V1 to V2. But volume changes from V1 to V2. Clear? What is work done? Area under the curve. The work done is equal to the work done is equal to the area under curve 1 2. Clear? That is what is work done is equal to P into V2 minus V1. This area. Clear? Now, I have already told in definition, when the gas is heated at a constant pressure, what is heat supplied? MCP T2 minus T1. Clear? Heat supplied. What is Q is equal to? MCP T2 minus T1. Heat supplied. Change in internal energy. Internal energy. Del U. Del U is equal to MCB T2 minus T1. Clear? This is del U. This is Q. This is what done. What is change in enthalpy? Change in enthalpy. Del H. M Cp T2 minus T1. Clear? This del H. This is about isobaric process or constant pressure process. Next, constant temperature process. Number 3, constant temperature process. Or isothermal process. Isothermal process. So this is isothermal process. One, two. In this case, temperature is constant. So volume increases, pressure decreases. Pressure decreases, volume increases. This is origin, volume, pressure P. Clear? This is B1, this is B2, this is P2, this is P1. This is expansion process. So the volume decreases from V1 to V2, pressure decreases from P1 to P2. See, this is constant temperature process. Means B is inversely proportional to P. So what is Boyle's law? B is inversely proportional to P. This implies PB is equal to constant. According to Boyle's law, B is inversely proportional to P. This implies PB is equal to constant. At a P is equal to constant. Clear? When temperature remains constant, the volume is inversely proportional to pressure. Here also, the pressure decreases, volume increases. When we will go to compression process, this expansion process. When we go through compression process, the volume decreases, pressure increases. So this process follows the law P is equal to constant. Clear? And this process follows Boyle's law. Hence, the expansion according to Boyle's law is isothermal. Clear? This is law Pb is equal to constant. When the gas is heated, in such a that the temperature remains constant. The temperature of the gas remains constant. Then the process is called isothermal, constant temperature or isothermal process. Clear? Since Boyle's law assumes constant temperature of the gas. Hence the expansion according to Boyle's law is isothermal. Clear? Also, the expansion curve The expansion curve follows the law if B is equal to constant. Clear? If B is equal to constant. Now, if B is equal to constant, the same place, what P is equal to? C by B, constant by B. Also, what is P1 B1 is equal to? P2 B2. Clear? P2 B2. What done? What is what done is equal to? W. Integration of P dV. What is P? Limit 1 to 2. What done is equal to? Integration of P means C by B into dV. Limit B1 to B2. Because the integration is done with respect to B. So limit starts from B1 to B2. So what is this? C ln B, limit B1 to B2. What is what done is equal to? What is C? C into ln B2 by B1. What is C? What is C? C is equal to P B joule C. The same place. B1 is equal to B2 B2 is equal to C. Clear? Put the value either P1 B1 here or P2 B2 here. Also, what is P1 by P2 is equal to? B2 by B1. Clear? So P2 put P2 by B1 value, P1 by P2 here. Now, what is what done is equal to? P1 B1 ln B2 by B1. What is P1 B1 or P2 B2 ln B2 by B1. This is formula for what done. Clear? Or also you can put B2 by B1 is equal to P1 by P2. So what is what done is equal to? P1 B1 ln P1 by P2 or P2 B2 ln P1 by P2. Clear? This is formula for what done. What is P1 B1 MR21? Also you can put P1 B1 is equal to MR21. Also we can put what is P1 B1 is equal to MRT1 or what is P2 B2 is equal to MRT2. Clear? These are all values for what done. Next, change of internal energy. Next, change of internal energy. Del U. What del U is equal to? M C T2 minus T1. M C T2 minus T1. Here T1 is a T2. So this cancels each other. This is 0. This is equal to 0. So what is del U is equal to 0. Next, heat transfer. Heat transfer. Q. What is Q? W plus del U. This is 0. What is Q is equal to W? Means P1 V1 ln V2 V1 or P1 V1 ln P1 by P2. This is heat supplied. Similarly, change in enthalpy. Change in enthalpy. Del S M Cp T1 is T1. This is 0 because T1 is equal to T2 cancels each other. So this quantity is equal to 0. So delta H is equal to 0. Clear? This is about what done? Change in internal energy, heat transfer, change in enthalpy. Next I will do adiabatic process. Number 4. Next, number 4. Adiabatic process. Adiabatic process or acentropic process. Clear? This is PV diagram. This is volume V. This is pressure P. This is 1, 2. Initial state 1, final state 2. Expansion process. This is P1. This is P2. This is V1. This is V2. Clear? So this is B. This is P. The expansion process follows the law PV gamma constant. Clear? This is an isolated process. Means the system surrounding neither exchange heat between each other. Do not exchange heat. Means the system or surrounding neither receive heat nor gives out heat. Clear? This is considered as an isolated process. Isolated process, as in this case there is no exchange of heat. There is no exchange of heat between system and surrounding. Between system and surrounding. Clear? No exchange of it. Clear? That is the system neither gives neither gives nor nor receives heat with surrounding. That is Q is equal to 0. Clear? The heat supplied, that is Q is equal to 0. The gas expands. In this case, the gas expands by doing some external work. Some external work. Clear? The following points should be considered. The following points should be considered for this process. Number one, no heat transfer takes place. No heat transfer takes place between the system and surrounding. That is Q is equal to 0. That is Q is equal to 0. Number two, work of some nature or work will be done by expanding the gas. Number three, the process is frictionless. Clear? Now I have derived the work done, energy, enthalpy for the process. Clear? Consider the adiabatic expansion of a gas. Adiabatic expansion of a gas from 1 to 2. Clear? 1 to 2. Let E1, B1, T1 is equal to initial condition of a gas. T2, B2, T2 is equal to final condition of a gas. Clear? The expansion process follows the law. The expansion process follows the law. P to the gamma is constant. P to the power gamma is equal to constant. Where what is gamma is equal to? Adiabatic index. Adiabatic index. Clear? Now what done? What done? What double is equal to? Integration of PdV. Clear? 1 to 2. This is general formula for what done? Integration of PdV. I will give some definition theory after this completion of the class. Now what is P? We know P to gamma is constant. What is P is equal to? C by B to power of gamma. Also, P to gamma constant. The same place P1 B1 to the gamma is equal to P to B to power of gamma. This can also put where required. If required, I can put all the values. Now put value of P here. This value of P here. Now what done is equal to integration of 1 to P C by B to power gamma into dV. So C into D by B to gamma B1 to B2, because integration with respect to B, so the limit starts from B1 to B2. So what is what done is equal to C into B to power of minus gamma plus 1 by minus gamma plus 1 limit B1 to B2. What is C? P1 B1 gamma is P2 to gamma. This is equal to C into B to power of 1 minus gamma by 1 minus gamma limit B1 to B2. So what done is equal to C into B2 to the power of 1 minus gamma minus B1 1 minus gamma by 1 minus gamma. Put C is equal to here P2 to the power gamma, here P1 B1 to the power gamma, because when for equating both base the power can be added or subtracted. So for same base S to the power of m, S to the power of n is equal to S to the power of m plus n. Clear? Here also C is equal to P to B to power n gamma into B to power of 1 minus gamma minus, here I will put P1 V1 gamma into 1 minus gamma whole by 1 minus gamma. Clear? This power added because both base same. Here also both base same, so power can be added. So this is equal to P2 into V2 power of gamma plus 1 minus gamma minus Q1 into V1 power of gamma plus 1 minus gamma whole by 1 minus gamma. Clear? Gamma cancels. What is work done is equal to? Now, what is work done is equal to? P2 and V2 minus P1 V1 by 1 minus gamma is equal to, what done is equal to P1 V1 minus P2 V2 by gamma minus 1. This is what done. Clear? Now, change in internal energy. Change in internal energy. Del U. Del is equal to M CB T2 minus T1. Clear? Heat transferred. Heat transferred. Q 0. Here also, after finding the answer, when you apply this formula, double product delta U, automatically this becomes 0. Because if W comes plus 100 kilojoule, del U will be minus 100 kilojoule. So when you added, this quantity becomes 0. Clear? Similarly, change in enthalpy. Change in enthalpy del S M Cp T2 minus T1. Clear? Next, number 5 process, polytropic. Process number 5, polytropic. Polytropic process. This process follows the law Vn constant. Same process, same formula as additive process, but we can replace gamma in place of n. Clear? In same process, we can solve the answer, find the answer. This is volume, this is pressure, same diagram, Vn constant. Clear? So this is 1 to V2, V1, E2, V1. So this is volume V. This is pressure P. When the gas is heated in such a way that the expansion curve follows the law P to the power of n constant, where n is equal to polytropic index. Then the process is known as polytropic process. Clear? In this process, the work done will be found out the same procedure as added process. In the same procedure as additive process, but by replacing gamma in place of n or by n. Clear? Now, what is work done? Now, what is work done is equal to V1 minus V2 by n minus 1. Clear? Change in internal energy. Del U is equal to m Cb T2 minus T1. Heat transfer Q is equal to double per del U. You add both the quantities, you can get the formula Q is equal to gamma minus n by gamma minus 1 into work done. Clear? What is work done? Gamma minus n by gamma minus 1 into V1 minus V2 by n minus 1. I will derive this formula next class. This is a very important question. For pure question 16 marks. Next class I will derive this formula. This is a long question. And change of enthalpy. Change of enthalpy. Del H. Del H is equal to M Cp T2 minus T1. Clear? The long question. Next class, I will derive this formula and I will derive another formula. What is Cp, what is Cb, what is gamma, what relation between P, Bt, pressure, volume, temperature. Clear? The detail I can discuss next class. Please make, share, like, share, subscribe and watch the video. Thank you. Thank you.